Perfect.
Yes, I
Wonderful.
think.
We'll get straight into it. So you've got 5 minutes.
Great. Yeah, thank you. Thanks so much for having us here. So I'm Giulio. I'm a process chemist, and I'm joined here by Timo, who's a biotechnologist. And we wanted to show you a part of our ecosystem around active learning that we are using at Bayer. So more for the chemistry and biotechnology side. So at Bayer, we have three divisions, and two of them are heavily involved in active learning, as we will present here today. I am from group that deals with process design and process development. We have this group in pharmaceutical division and in crop science division, but at Bayer we also work cross-divisional, especially in bioengineering group. We also have applied mathematics group that designs algorithms and applications for us to work better, and we interact with them very, very heavily. And we also have an external ecosystem that allows us to do technology transfer and scouting of new innovations with an entrepreneurial system called the Life Science Collaboration that works Bayer-wide to send colleagues to different institutions and get talent from institutions all over the world. And you will see two academic works that we did together with these colleagues at MIT and in Linz in Austria. Um, so I'm handing over to Timo for one example that harnesses active learning for our typical use case at Bayer.
Yeah, thank you. So yeah, I will talk about this example of closed loop optimization for accelerated bioprocess development. And yeah, here on the left, you can see our scale down cultivation systems where we can do up to 48 parallel microbial process optimizations for various biotech applications. And we can really do automation cycles here with minimal human involvement for media and process development because we have these so-called biolector systems for the people who know these implemented in a liquid handling platform so we can interact with our reaction systems through liquid handling. And then we have AIDED, which is also similar as the previous talk. It's an end user tool. So really the scientists can access this for multi-factor optimization. And here we use model-based and the AI-driven design of experiments to focus experiments in the promising design spaces. And by combining this, so AIDED does the design of experiments. The experiments are exported on the robot. The robot pipettes all the different media compositions, runs the experiment, data is reintegrated into AIDED. And with that, we can do this rapid optimization, for example, as shown here for enzyme production, where we can go to through consecutive DOEs classically, and then also show that it works. Our model improves, our predictions improve, and then we have this 2.5-fold increase in volumetric enzyme activity here. And this was then actually also even validated in larger scales. And with that, back to Julio. Time is running.
Thank you. And another example from chemistry is how we applied AIDIT to typical process optimization of Bayes-Hillman reactions. As you can see here, many variables, continuous and categorical variables that were optimized by using less experiments than typical full factorial DOE. And overall, what is interesting here at this allowed us to, once scaled up, save several millions of years of saving in production cost due to lowering of usage rates and very strong reduction in reaction time. And last slide on the academic collaborations that we are pursuing, one of them in the area of data analysis, because we know that noisy data is a challenge for optimization systems. And so we are trying to work with different types of data analysis techniques, in this case, open source Python package that harnesses the full UV spectrum of an HPLC run, and on the other side, also explainable AI to better understand what type of predictions a model actually does. So we have the implicit domain knowledge of a chemist that can work better together with the predictions of a black box model by using explainable AI techniques. And with this, our questions to the round. How similar do processes actually need to be in order to benefit from a transfer learning approach? And the second questions, because everybody's always talking about KPIs, what would be needed in your organization to have a 10x efficiency increase thanks to active learning? Systemic organizational changes, all sorts of changes that you could see in your organization to reach this goal.
Perfect.
Thank you very much.